Ancient people only knew as much about the sun as they could see with the naked eye, but today we have telescopes and other technology that helps us make better observations. So what if we could investigate our sun up close? Recently, scientists have designed and launched a probe on its first in human history journey to the sun. So how close did the spacecraft get? What did it find? And why didn't it melt? Get ready to discover this and some other mysteries of our neighboring star. Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about strange things discovered around the sun. So if you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. Without the sun, no life on Earth would be possible, but this gigantic ball of hot plasma can also threaten us. Its bursts of radiation, also known as solar flares, and its explosive ejections of plasma, called coronal mass ejection, accompanied by intense magnetic fields, can be frightening. Because of solar storms, our telecommunications, navigation systems, and power grids can fail to operate properly. So we haven't been able to understand the sun and how it works, or when it's going to throw a massive ball of fiery plasma our way. This is why scientists have long dreamed of studying our star from a close distance. We know that the solar wind is a constant stream of charged particles that gained enough speed to escape the sun's outermost layer called the corona. But we don't know how energy and heat move through the corona and what accelerates solar energetic particles. Astronomers have been seeking the answers to these questions for about 50 years, but to no avail, as finding answers meant sending a spacecraft through the corona that reaches about 1.1 million degrees Celsius, and it seemed impossible to accomplish until recently. This is what the Parker Solar Probe was made for, and it's truly a marvel of human technology. In 2018, NASA successfully launched the Parker Solar Probe to revolutionize our understanding of the sun and space weather. Parker Solar Probe was designed to become the first spacecraft to enter the sun's atmosphere. It's the size of a small car, and it weighs 685 kilograms. The spacecraft has several important instruments on board, including the Solar Wind Electrons, Alphas, and Protons Investigation, or simply called SWEEP, which will sample particles in the solar wind. The instrument has 4 sensors that calculate the abundance of particles. Another tool that Parker is equipped with is called Integrated Science Investigation of the Sun. It's made of 2 separate instruments, each having a different energy range. The instrument can weigh highly energetic heavy ions, electrons, and protons moving through the sun's atmosphere. Lastly, made of magnetic meters and electric field antennas, the Parker Solar Probe uses electromagnetic fields, an investigation tool to analyze magnetic fields, radio emissions, and the density of the sun's corona. But how can the Parker Solar Probe get so close to our sun without melting? To study the sun under such extreme conditions, the probe and its instruments are equipped with a super reflective coating and a shield that measures 2.3 meters in diameter facing the sun. The shield, called the Thermal Protection System, is made of 11.5 centimeters of thick carbon composite. This makes the Parker Solar Probe capable of withstanding temperatures outside the spacecraft that reach roughly 1,370 degrees Celsius. The Parker also has sensors to let it know that the heat shield has been adjusted when needed. Another level of protection is located on the inside of the probe. Parker has a dual array of solar panels and smart cooling system. The cooling system circulates water behind the solar cells, where it gets heated. Then, this same water is pushed down into the radiators, where it's cooled. All of this makes the Parker probe resistant to heat and radiation like no other probe before it. And even with the level of protection and low density of the corona, Parker can only stay in the layer of the sun for a few hours. But how in the world is it possible to even send a probe toward the sun? As we know that the sun is 150 million kilometers away and would take forever to get there, as reaching the sun isn't that simple. When a spacecraft is launched into space, Whatever velocity rockets give it will be superimposed on top of the Earth orbital velocity, meaning that we can either cause the spacecraft to have more or less orbital energy than the Earth does. So we can either boost it to a higher, less tightly bound orbit with respect to the Sun, or deboost it to a lower, more tightly bound orbit. Most of our space probe missions use planetary gravity to accelerate spacecraft and give them more orbital energy. But with Parker, scientists needed to do the opposite, make it lose orbital energy. The Parker Solar Probe has used multiple slingshot orbits, using Earth, Mercury, and mostly Venus to enable it to get this close to the Sun. And each time it goes around the Sun, the probe picks up an insane amount of speed. Astronomers call it gravity assist, and it helps Parker narrow its orbit around the Sun and brings its perihelion about 6.4 kilometers closer. So did it actually touch the Sun? Unlike Earth and some other planets, the Sun doesn't have a solid surface, but it still has a boundary. The point where the Sun's gravity and its magnetic fields keep the solar material is called the Alfvén critical surface. According to astronomers' calculations, it should be anywhere between 10 to 20 solar radars from the surface, which is roughly 7 to 13.8 million kilometers, and scientists believe that it makes our Sun's boundary. With every gravitational maneuver, the spacecraft narrowed its distance to the Sun, and as it did, so astronomers searched for signs that the Parker Solar Probe had reached the critical surface. So what happened when NASA's spacecraft arrived at its destination? As the probe passed through a pseudo-streamer, or a loop-like structure in the corona of the star, the whirlwind of particles started moving much slower, limiting the impact on the probe. This meant that the magnetic fields were dominant in that region so that no particles could escape. It was a proof that the Parker was inside the Alfvén critical surface. The spacecraft then recorded a video of coronal streamers moving past it, and it was the first time scientists were able to see these mysterious objects from up close. The data collected from the probe shows switchbacks and zigzag structures in the solar wind are quite abundant close to the star. Before this, astronomers thought these exact structures were rather an abnormality occurring near the Sun's poles only. But the spacecraft helped scientists conclude that these structures originate in the solar surface and are quite common. Parker has also discovered that the critical surface was 18.8 solar radar from the solar surface, and it took 8 flybys and over 3 years to finally get there. And this is it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.